All right, let's get started with the midterm review. The first question is a simple process analysis question. In this problem, there are 5 workers and 7 steps. There are 5 workers. Let me make our 5 squares. The first worker has 3 minutes worth of work, 3 seconds worth of work. The second has 40. Third has 120 seconds of work. Notice it says 2 minutes. Fourth has 45, and the fifth has 40 seconds worth of work. As there is 1 worker in each station, the capacity is 1/3 units per second, 140 units per second, 120 units per second, 1/45, and 1/40 units per second. Well, you can notice that this has the slowest capacity, so worker 3 must be the bottleneck. Some people wrote, instead of saying worker 3, said step 5, but it's customary to call the resource the bottleneck, not the step. Okay? Even if there is 1 step per worker, we like to call the resource as the bottleneck, not the steps. The second question is, what is the capacity of the assembly line? Well, the capacity of the assembly line is determined by the capacity of the bottleneck. The capacity of the bottleneck is 1/120 units per second. So this must be the capacity of the process. But remember, the capacity of the process, we earn the answer in terms of units per hour. To convert from units per second to units per hour, well, we have to just multiply it by 60, it becomes units per minute. We multiply it by another 60, it becomes units per hour. So we have 3600 divided by 120 equals to 30 units per hour. That's the capacity of the process. The next question is, what is the utilization of the worker 4? Well, utilization of the worker 4 is defined as the flow rate and divided by the capacity of worker 4. This would make sense because utilization is just how much you work divided by how much you can work. Flow rate determines how fast you have to work. Well, you have to work at the speed of 1/120 units per second, but you have the capacity of working at 1 divided by 45 units per second. So your capacity is 1 divided by 120 divided by 1 divided by 45. So 1 divided by 120 multiplied by 45 divided by 1. This comes out to be 37.5%. Right? Okay. Let's go to the next question. In this question, what we have is a pharmaceutical development company. So how pharmaceutical companies works is they invest in a lot of ideas, and when they see there's enough market potential in that particular idea, they file a patent. So they invest on a lot of technologies. When they see it has market potential, they file for the patent. After the patent is filed, they invest on development of the product or the drug or whatever it is. When the product is ready, the government allows them to sell without any competition for 12 years. So this is 12 years. This might be infinite, or doesn't have. We don't. There's no mention of how long this takes. But we are more concerned about this phase, this undergoing development phase. According to the question, this lasts for 1 year. And the question says, how many are there on average in this phase? So that is hinting towards Little's law, because Little's law connects inventory with rate and time. As we are asking how many drugs are there in this development phase, we are concerned with inventory. if that is what we need to find what T is and what R is, and that must be given in the question. Well, T is obvious. The average development process lasts for 1 year. Remember, we don't care about the standard deviation because Little's law is all about only average values. This T is 1 year. We want to know what is the rate. Well, the rate says is 1 units every 5 months. Okay, 1 units every 5 months. But we want rate in terms of flow units per time unit. 1 units every 5 months is same as saying 1 over 5 units per month. So we have R equals to 1/5 and T equals to, well, we can't use 1 year because this is in terms of units per month. We have to convert T into 12 months. The answer is 12 divided by 5, which turns out to be 2.4 units. So at any given time, during this boundaries of process, there are 2.4 units that is undergoing development. Now it really doesn't matter how many lines are there. It says there are 3 independent development centers. It really does not matter how many development centers are there. On average, 1/5 units are coming out. On average, there are 12 units. We don't care if there are 10 development centers or 20 development centers. Okay. The next question was probably the most straightforward question. In this question, I've given you sales. As sales is 7,000 million, and what I told you is COGS is the 60% of it. So 60% of this 7,000 million is 0.6 multiplied by 7,000 million, which is equals to 4,200 million. Now the question says inventory turn equals to 25. So the question is, how much inventory must they have? Well, we know the formula that inventory turn equals to COGS divided by inventory, right? But we already have inventory turns, that is 25. We have COGS of 4,200 million. Then we want to find what the inventory is. Well, that means inventory is nothing but 4,200 million divided by 25, which turns out to be 168 million. All right. Next question says, well, Trevor Bob sells this item for $20, but his COGS is $12, and his holding cost is 20%, and he has an inventory turn of 25 units. What's the inventory cost per unit per year? Right? Inventory cost per unit. So instead, we don't use selling price, we use COGS. So that COGS equals to $12. Holding cost is 20% of this $12, which is equals to $2.4. So that is, if he had to hold the unit for the whole year, it would cost him $2.40. But he flips it 25 times. That is 2.4 divided by 25, which is about $0.096. That is 9.6 cents. So the per unit cost is about 9.5 cents. Okay. The next question is, there are multiple ways to do this. The traditional way, looking at the time, is slightly difficult, but let me do that. So we start with 480 minutes, right? We lose 15 minutes for the break, 45 minutes for the meal break, and 60 minutes for the downtime. That's easy. We also lose 3,000 units for the reject. 3,000 units is about worth 3,000 divided, because in each minute you can produce 90 units, it's worth 3,000 divided by 90. But there is something missing, as I pointed out in the question. What that is if this was the case, let's see, this would be equal to 480 minus 120 minus 33.33. This would give you 326.66 minutes. But as I pointed out, you're missing something. You can test for that by saying, well, if you're working on the full capacity for 326 minutes, 326.66 minutes, you should be able to produce 326.66 multiplied by 90. You should have been able to produce 326.66 multiplied by 90. You should have been able to produce 399.4 good parts. But that's not what really happened. We produced only 27,000 good parts. That means they were slacking at some point. They underproduced by 29,399.4 minus 27,000, which equals about 2,400 parts. They slacked by 2,400 parts. How much is 2,400 parts worth in terms of minutes? Is 2,400 divided by 90 is equals to 26.66 minutes. So altogether, they gave us only minus 26.66 minutes of good work. That is, they gave us 300 minutes worth of good work. Potentially, they could have done 480 minutes worth of good work, but they did only 300 minutes of good work. That's why 300 divided by 480 is 62.5%. There's a slightly easier way to do this, and that is, well, they did, it takes a little bit of thought, because it's a ratio. It really doesn't matter. You take the ratio of minutes or the units of goods produced. They were able to produce 27,000 units of good pencils. They should have been able to produce 480 multiplied by 90 if they worked hard all 480 minutes, which comes out to be 27,000 divided by 43,200, which should also be equals to 62.5%. So you use pencils, you use time, you should get same 62.5%. So this underprocessing of 26.66 minutes of underprocessing would not be obvious, but as I pointed out, they are here, there's one piece of information was missing, and if that was the only mistake you made, I didn't duck you too many points. But underprocessing is also a waste, and I hinted that that waste is happening here, so you should have been able to track that. Well, the next question is, there are two multiple choice questions. Quality has two dimensions, conformance and performance quality. Which of these captures to what extent we are able to deliver on the promise that we made to our customer? Well, as I told you, performance quality, Mercedes is a good car not because they are built because we all agree to it. It performs good. That's the idea. That Mercedes is a better car than a Camry or so. Whereas we think Toyota is a good car because they give us what they promise us. That is, being able to deliver on what a company promises on is a kind of conformance quality. That's the conformance dimension of quality. Whereas being able to produce better product. Now again, performance quality might mean different for different people, but we all agree Mercedes is a better car than Corolla. So that is performance quality. So this question of what is this dimension which measures if we are delivering what promise we made to the customer is conformance quality, conforming to what we delivered. Which of this is a flow unit centric waste? Well, remember there are two kinds of waste. One is flow unit centric, one is process centric. There are 5 kinds of process centric waste. There's 2 kinds of flow centric waste. The 2 kind of flow centric waste is inventory and waiting. Inventory and waiting are really not as different as it sounds. They're probably just orthogonal to each other, as I pointed out in the class. So you should go back and look at this slide. The flow centric waste is waiting out of those 5. Well, hope you're able to correct all the mistakes you have, and at the end I like to apologize a little bit on being a little pissed in the class today, and hope I didn't offend too many people. Alright.